In this video, we will see further sums from the exercise. Question number 8. For any vector A, prove that the given equation, which is A vector product with I cap magnitude squared plus A cross product with J magnitude squared plus A cross product with K magnitude squared is equal to 2 A vector magnitude squared. So let's define vector A equals x I cap plus y j cap plus z k cap. So magnitude of A will be equal to square root of x squared plus y squared plus z squared. Therefore, magnitude A squared is equal to x squared plus y squared plus z squared. Now, the vector A cross product with I cap will be equal to the determinant I cap, j cap, k cap, x, y, z, 1, 0, 0. And that will be equal to I cap will be 0 because 0 minus 0 will be 0. For j cap, it will be minus j into x into the 0 minus z. So it will be a plus z j cap. Similarly, for k cap, it would be x into 0 minus y. So it will be minus y k cap. So the magnitude of A cap, A vector cross product with I cap squared will be equal to z squared plus y squared. Similarly, vector A cross product with J will be equal to the determinant I cap, j cap, k cap and x, y and z. And for j cap, you would write it as 0, 1 and 0, which is equal to 0 minus z I cap minus z I cap, and for j cap it will be a 0, and for k cap it would be x minus 0. So plus x k cap. Therefore, magnitude of A vector cross product with j cap squared will be equal to z squared plus x squared. Similarly, A vector cross product with k cap will be equal to I cap, j cap, k cap, x, y, z, 0, 0, 1. And that's going to be equal to I cap into y. So y I cap minus j cap will be x minus x j cap, and k cap will be 0. So the magnitude of A cross product with k cap squared will be equal to y squared plus x squared. So adding the 3, adding 1, 2 and 3, we can say A vector cross product with I cap squared plus A vector cross product with j cap squared plus magnitude of A vector cross product with k cap squared will be equal to z squared plus y squared plus z squared plus x squared plus y squared plus x squared, and that is equal to 2 times x squared plus 2 times y squared plus 2 times z squared. So taking the 2 as a common factor, 2 into x squared plus y squared plus z squared, and that is equal to our A vector squared here. So it's equal to the magnitude of A vector squared. Therefore, LHS is equal to RHS, and hence the proof. Question number 9. Let vector A, B, C be unit vectors such that A dot product with B is equal to A dot product with C is equal to 0. And the angle between vector B and C is given by pi by 3. Prove that vector A is equal to plus or minus 2 by square root 3 into B vector cross product with C vector. What is given to us is given A dot product with B is equal to A dot product with C is equal to 0, which implies vector A is perpendicular to both vector B and vector C. Further, we know that B cross product with C will be perpendicular to vector B and vector C, which implies vector A is parallel to B vector cross product with C vector. So we can write vector A as T times vector B cross product with vector C. Now what is given to us is that it's given to us that angle theta, the angle between B vector and C vector is pi by 3. Therefore, our vector B cross product with C is equal to, the magnitude is equal to vector B into vector C into sine. The angle between B and C is pi by 3, it's pi by 3. So further, that's equal to B and C magnitude of 1 as their unit vectors. So this is equal to sine pi by 3, which is root 3 over 2. Now let's bring our vector A magnitude will be equal to the magnitude of T into B cross product with C magnitude. So that's equal to T times the magnitude of B cross product with C. But we already have the magnitude of B cross product with C as root 3 by 2. So which is root 3 by 2 times T. However, our magnitude of vector A is a unit vector, so this should be equal to 1. So this implies that our T is equal to 2 by root 3. Therefore, vector A is equal to T times of vector B cross product with C is equal to plus or minus 2 by root 3 B cross product with C. Hence the proof. Question number 10. Find the angle between the vectors 2i cap plus j cap minus k cap and I cap plus 2j cap plus k cap using vector product. So let us define, let vector A is equal to 2i cap plus j cap minus k cap and vector B equal to I cap plus 2j cap plus k cap. Now the angle theta can be defined using the formula sine theta is equal to the magnitude of A cross product with B divided by the magnitude of A into the magnitude of B. So let's find what is the magnitude of A first. That's equal to square root of 2 squared plus 1 squared plus 1 squared minus 1. So I'm just putting it as 1 squared. So that will be equal to 2 plus 4 root 6. Similarly, the magnitude of B is equal to square root of 1 squared plus 2 squared plus 1 squared, which is also equal to square root of 6. Now let's find what is A cross product with B. That's equal to the determinant I cap, j cap, k cap. The coefficients of I, j and k will be for A vector 2, 1, minus 1, and for B vector it is 1, 2 and 1. So finding the determinant value, we get 1 plus 2. So it's 3 I cap minus j into 2 plus 1. So it'll be plus 3. So minus 3 j cap. Then k into 4 minus 1. So 3. So plus 3 k cap. Therefore, the magnitude of A cross product with B is equal to square root of 3 squared plus minus 3 squared plus 3 squared, which is equal to square root of 3 times 9. So it's, you can call it as 3 times 9, which will be equal to 3 root 3. Therefore, our sine theta is equal to 3 root 3 divided by magnitude of A is root 6 into root 6, which is equal to 3 by root 3 by 6, which is equal to root 3 by 2. Therefore, our theta is equal to sine inverse of root 3 by 2, which is equal to pi by 3. Hence the result.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.